thinks that Donald Trump is going against the WHO, which maybe he is going against the WHO, but they think he's going against Bill Gates. But Bill Gates funds the very company, and DARPA funds the very company that is working with Operation Warp Speed to get 500 million vaccines, apparently now by November 1st, and a billion in 2021.
Well, that's the thing. The Hegelian dialectic will allow you to advance your agenda. It's a good cop, bad cop thing. So, like if I want to get something done, then I can talk to my coworker and be like, all right, you play this role, I'll play this role, we'll get it done. So like it's whoever comes in with a solution then is seen as this person that's capable leader, this, that, and the other. I mean, it's like, how bright does Donald Trump really need to shine to outshine Joe Biden? I mean, because for whoever's really stuck at that level with, left and right Biden and this and that, I was like, that's a joke anyway. I mean, that should be apparent, I think, at this point. But then he causes you to run into the arms of this guy, like you said, who's doing all this. So I think it's just scary when you really start to think about it like that from a 10,000-foot perspective. But I did want to talk about one thing that I am intrigued about. Good or bad, the guy, who whatever, he was talking about this. And I don't fully understand this yet because I'm still looking into it. It has a lot of side effects, but nobody really seems to understand why it even works. And it's got like these mysterious qualities. So anyway, here's something to read about. There's something associated. It can be used to treat Q fever, which is, I mean, are you kidding me? So, which is known as Query fever, and it's a disease caused by infection with the Coxiella burnetii. I can't even. It's a bacterium that affects humans and other animals. This organism is uncommon but found in cattle, sheep, goats, and domestic mammals, including cats and dogs. So, personally, I think what we might be seeing is Q fever. They can call it coronavirus, sure, but because when you get into this, it's treatment for malaria and things like that. So, because even Trump took, I don't know where I read about this a little bit ago, but when Trump first started taking hydroxychloroquine, he also took erythromycin the first week or whatever, and that's an antibiotic. And so what you see with a lot of these is that they'll take antibiotics with it and stuff because they're trying to kill what they think is a creature, like a parasite or a bacterium or paramecium, right. Call it whatever you want. Yeah. So we're going to talk a little bit about what this is and what it does, what the action is. And so anyway, again, I'm not an expert for anybody out there that thought I was. But anyway, let me read a little bit about this. This is the part I wanted to read about. And there's a term, once I catch it here in the reading, we're going to talk about biocrystallization, because that's kind of like the action that it works on. It's kind of interesting. Hydroxychloroquine increases lysosomal pH in antigen-presenting cells. In inflammatory conditions, it blocks toll-like receptors on plasmatoid dendritic cells. Toll-like receptor, oh my, pardon me. Didn't mean to click that. Sorry. All right. Toll-like receptor 9, which recognizes DNA containing immune complexes, leads to the production of interferon and causes the dendritic cells to mature and present antigen to T cells. Hydroxychloroquine, by decreasing TLR signaling, reduces the activation of dendritic cells in inflammatory processes. So it basically just keeps you from having an inflammatory response, right?
And sounds very like anti-inflammatory, like ibuprofen or steroids or something.
Yeah. And then in 2003, a novel mechanism was described wherein hydroxychloroquine inhibits stimulation of the toll-like receptor 9 family receptors. TLRs are cellular receptors for microbial products that induce inflammatory responses through activation of the innate immune system, which is something that's shared by all vertebrates. It's like an evolution, I don't believe in evolution or whatever. I'm just saying, like, they say that it's something that all spinal chordata, I think animals with spines or something, vertebrates. Something that all of them have. As with other quinoline anti-malarial drugs, because they're in this class, this family, the anti-malarial mechanism of action of quinine was not fully resolved. The most accepted model is based on hydroxychloroquine and involves the inhibition of hermosin biocrystallization. We're going to get into that in a moment, which facilitates the aggregation of the cytotoxic heme. Free cytotoxic heme accumulates in the parasites, causing death. So this, okay, let's say if it was malaria, they're eating your blood, right? which is kind of how I guess sickle cell must somehow also prevent the creatures from eating their hemoglobin because of the way it's shaped, or some way, shape, or form the key and mechanism doesn't work, whether it's lipid driven or however it's working there. But anyway, what it's saying here is that the hydroxychloroquine prevents the enzymes from allowing them to eat hemoglobin and expel it, and so they poison themselves and die. Well, okay, that's kind of interesting, but we're not fighting a parasite, right? You said we're fighting a virus, correct? Right?
That's what they say.
That's what they say. So anyway, let's continue to read here. Hydroxychloroquine increases the risk of low blood sugar through several mechanisms. These include decreased clearance of the hormone insulin from the blood, increased insulin sensitivity, and increased release of insulin from the pancreas. I didn't know any of that. That's kind of interesting. Hydroxychloroquine has been suggested to be a zinc ionophore, which is a chemical species that reversibly binds ions, and probably for transportation of something across the barrier. As you can see there, it goes from one side to the other.
The next half of that sentence is amazing.
Transports the ion and may derive
an
anti-cancer action from increasing intracellular zinc uptake. Whew. So it's better than COVID. It apparently destroys cancer.
Right. It helps you uptake your zinc that you're taking to help your immune system.
So really, if you didn't have enough zinc in your diet anyway, it may not benefit you wholly. It's kind of like when you take turmeric. It's not really beneficial unless you take it with black pepper, which then tremendously increases the bioavailability for it. So that's why a balanced diet's very important. You got to get all that stuff. Hydroxychloroquine can decrease tumor growth by cutting off fuels that promote mitochondrial function. There are multiple phase 1 and 2 trials testing the efficacy of hydroxychloroquines. No wonder they don't want this stuff out there. So anyway,
it's doing too much good.
Just wanted to talk about it a little bit because you hear so much about it, and so before we get too far off the topic, we'll talk about quinine, which is kind of related to this. And I found something very interesting. So before I get into the weeds here, quinine is a medication used to treat malaria. So it's just like the stuff we're talking about. But they can make it from a tree. It's an alkaloid. So it's effective.
Put it in tonic water.
Yeah, oh, actually, you're right. And if you notice, in a black light, it lights up. I didn't know that either. Now,
I know that.
Here's something I want to read about
UV light in the body.
Oh, there was a link about the UV light treatment for coronavirus too in the lungs. They had like these probes they could stick down in the lungs and flash them with UV light. Totally. Anyway, quinine is a flavor component of tonic water and bitter lemon drink mixers on the soda gun. So yeah, it's exactly what you're thinking, right? But hey, did you know that tonic water is designated by the letter Q? Representing quinine. So here we got Q fever being treated with Q.
Right.
I mean, it's kind of weird. I mean, I didn't know any of this stuff before I started putting together this segment, by the way. This is what was so weird about this dig. Anyway, there was another thing here that caught my attention here in the second part here. In Canada and Italy, quinine is used as an ingredient in the carbonated beverages, blah, 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 blah. In Scotland, the company AG Bar uses quinine as an ingredient in the carbonated.
That's weird.
So I just kept coming across all these weird little things that I thought, well.
Where can you highlight where AG Bar uses quinine as an. Why are we talking about him?
It's not him.
It's not him. It's a company. That's so weird.
It's like a caffeinated beverage or something. Yeah, totally, man. It's in Scotland though, so I mean maybe it's just racist for us to think that or something. I don't know. That maybe it's so common over there that they'd laugh at us over that. But I don't know. I still thought it was funny though. So you got your Q thing, the AG bar. What was it on this other one here? There was another one where we just found. I can't remember where it's at now. But there was another one we found there a minute ago. So yeah, those little things there were fun to point out. And then let's go into this biocrystallization concept here, because this is basically how it's saying that it's killing off the malarial parasite. It would be by doing this. So I'm just wondering how this is possibly connected. So of course, it did talk about the zinc uptake thing, so we got that too, right? But then it's also talking about how what that hemozomin stuff really is. It's actually like a mineral. Okay, so it causes the demineralization of things, basically. Blood-feeding organisms digest hemoglobin and release high quantities of free toxic heme. To avoid destruction by this molecule, the parasite biocrystallizes heme to form hemozoin. So the parasite biocrystallizes the heme. That means it produces crystals, right? Okay.
Okay.
To date, only definitively characterized product of hematin disposal is, sorry, that sentence messed me up. Hemozoin is, per definition, not a mineral, and therefore not formed by biomineralization. So what they're saying is it's created. So they're saying it's not a mineral, even though it's a mineral in a sense. And so heme biocrystallization has been found in blood-feeding organisms of great medical importance, including Plasmodium rhodiosus and cystosoma. Heme biocrystallization is inhibited by quinoline antimalarials such as chloroquine. So, and then there's another sentence here. Targeting heme biocrystallization remains one of the most promising avenues for anti-malarial drug treatment because of the drug's target is highly specific to the malarial parasite and outside the genetic control of the parasite. So, it's, in other words, they're saying it can't adapt. They found a perfect weapon against malaria parasites, is what they're saying, because it attacks this weakness that they can't overcome. And it's like they said that this is so perfectly designed to kill just this one thing because of it inhibits biocrystallization. So this is just my opinion, but you guys have heard me talk about how I thought that hydroxychloroquine might be linked to, because of the word chloro, meaning green, possibly having some kind of link to the pineal gland or something like that, because folks say that if you decalcify the pineal gland, you awaken its natural state. Well, if indeed hydroxychloroquine has an inhibiting effect on this biocrystallization effect, well, biocrystallization, even though it sounds really cool, is actually a bad thing, because we as humans do not absorb minerals, and so But in this case, we're only hearing this word in the context of these creatures that are basically binding up waste products and excreting crystals into our bloodstream, and so then that's what we're basically dying from is the toxins from that, essentially. That, and they're eating your hemoglobin, so you're getting a double whammy there. But so this hydroxychloroquine interrupts that biocrystallization phase. So if you don't have malaria and you're taking this, does that then have other possible side effects like decalcifying your pineal gland? I don't know, but it's just something that makes you wonder because of what you also find in Revelation about the seal on the forehead and the spirits not attacking people with the mark on their forehead, etc., and then also comparing that to the grass and the trees because they're not allowed to hurt that either. Because I was doing a little bit of a study on the scorpion men, which I don't have any links up for that. Oh yeah, sorry, I forgot to share this link. But anyway, the scorpion men, apparently they come from the pit, and that might be where the Tower of Babel was built, around these 7 hills or something like that. So I was getting into a study there, and I haven't really figured out the true connection yet. Like what would tie the Sumerian tales even with it to our modern day, So I'm working on a study of all that. So if I figure it out, I'll share it with you guys.
Do you have an open mind? Can you suspend judgment for a moment? Most people can't. But what if your job depends on it? What if the freedom to hug people depends on it? What if your life depends on it? Here's a new theory. First, consider that we live in a world where everything is toxic. The soil, the water, the air, our food, even our medicines are toxic. Even stress can be toxic. Now imagine that all these toxins are poisonous to us on a cellular level. Imagine that our cells have a defense and respond to this situation. Poisoned genetic material, either RNA or DNA, is packaged up and sent out of the cell in tiny balls of protein. Let's call these balls of genetic material exosomes. Let's imagine that exosomes can act as messages to alert other cells of a particular poison, and so all throughout the body, more and more cells package up the poisoned material and release it. Also, at certain times of the year due to temperature cycles, humans tend to purge a high number of these poisoned genetic materials out of the body, resulting in symptoms of illness. These exosomes neither cause illness nor are they infectious, though they do appear to spread throughout the body. Now, that's exosome theory. Let's move on to the established theory of viruses. Viruses are generally regarded as not alive. They have no cellular structure and do not reproduce on their own, though we do have trillions of them inside our bodies. They are tiny bits of genetic material, either RNA or DNA, packaged in tiny protein balls that appear to exit and enter cells. Sound familiar? We believe that some of these entities are infectious and pathogenic, transmitting amongst humans and reproducing inside our bodies, causing illness and death. So let's look at the situation for this coronavirus and compare what is happening to these two theories. Let's first consider the origin story of the coronavirus. A group of people had a respiratory illness unresolved by antibiotics, so medical officials began looking, of course, for a virus. What they eventually found under the electron microscope were small protein balls being excreted by the cell. Okay, first comparison. This would make sense in both exosome theory and virus theory. Then they searched for and found an RNA fragment that they had not seen before in some of these patients. This would make sense in both exosome theory and virus theory. Now, they did not prove that they could infect somebody or an animal with a purified form of this so-called virus. They simply assumed that this RNA fragment was the cause of the illness they saw in some patients, and they assumed it was contagious. So do you know how the tests work? It's not a binary test, like a pregnancy test. It's called a PCR test, and it involves amplifying genetic material by doubling it in dozens of cycles until you have billions or trillions of the original molecules, and then using those results to determine if you have enough of the identified RNA fragment to be considered positive. Here's the thing. At a certain point of amplification, every single person would test positive. They use an arbitrary cutoff point where they stop doubling the material. That cutoff point is different amongst different tests for COVID-19. In fact, there were 10 different cutoff points amongst the 33 tests approved by the FDA. Seems a little strange, right? You might find it interesting that the Nobel Prize-winning inventor of the test did not believe it should be used to diagnose infectious illness. And perhaps you've heard about some of the problems with the test, such as the high rate of false positives. But in any case, let's say that after 37 times of doubling a specific genetic material they found in your body, they determine that you have enough of the RNA they are looking for to be considered positive. This could make sense in both exosome theory and virus theory. But clearly there are clusters of people getting ill. Look at New York City. It must be a virus. However, if you are being poisoned by something in your environment, it's likely people near you are too. And if we commonly purge these poisons during specific times of the year, many people may have symptoms of illness all at once. This fits either theory. Now, here's where things get interesting. Let's go to the Diamond Princess cruise ship situation. Did you know that people who were bunked together for days had conflicting positive and negative tests? How could one person have this highly infectious illness but not transmit it to somebody bunking with them for days? This would make sense in exosome theory, where the balls of RNA are not contagious, but it would not make sense for virus theory, where the balls of RNA are supposed to be highly infectious. Let's take a look at the first case of transmission in Illinois. A woman traveled to Wuhan, came back, and both she and her chronically ill husband ended up testing positive. Medical authorities then tracked over 300 people who had had close contact with them to see who acquired the virus. And guess what? 0 positives. This again would make sense in exosome theory, since exosomes are not contagious. But it would not make sense for virus theory, where this is supposed to be an infectious virus. In fact, do you know that there are many documented cases all around the world of patients testing positive for this RNA fragment with no relevant travel history and no known possible contact with somebody who was infected? These were people in the middle of nowhere, early on in this whole crisis, who suddenly were testing positive. This would make sense, again, in exosome theory, where the RNA is being produced as an immune response within our cells. But it would not make sense for virus theory, where you are supposed to have had contact with somebody with the virus. What about the high levels of people testing positive who don't get sick? In fact, 80% of people testing positive are either asymptomatic or have slight cold symptoms. Why? This would make sense in exosome theory, since the RNA fragments are not the cause of the illness. But it would not make sense for virus theory, where this virus is supposed to cause the illness. Things get even stranger. Did you know that some people go from testing positive to testing negative to testing positive again in a matter of days? And that would make sense for exosome theory, where perhaps the cells are simply releasing more or less of these exosomes depending on certain conditions. But it doesn't make sense in virus theory, where you are supposedly infected until you have rid yourself of the virus. So which of these theories seems more likely to you? What if you heard that there are virologists who believe that viruses are actually exosomes? What if I told you that doctors and other scientific experts also believe this? Ultimately, regardless of which theory you believe in at this point, the established infectious virus theory or the emerging theory of exosomes, how confident are you in the PCR test? Are you really interested in having your life hinge on the results you get from this potentially meaningless test? Do you want your loved ones tested? Do you want to be tested? Or shall we perhaps refuse the test?